Wonderful. Good evening, everyone, and welcome to Fairfax County's Department of Public Works and Environmental Services Public Information Meeting. Our topic this evening is the Accotink Gravity Sewer Project. My name is Ellen Gray, and I'm your facilitator for this one-hour meeting. Our meeting runs to 8 p.m. At the end of this hour, you will have been informed of the project. You will have been able to ask questions and or post comments, and you will have learned how you can be kept informed. But before we start the program, please allow me to review a couple of logistics of this technology platform. Tom, if you go to the next slide. At the top of the screen, you will see the icon with a question mark and the letters Q and A. If you click there, you will have a new window that will open. And at the bottom of that window, highlighted, you will see the words, make an announcement. If you click there, you will be able to type your question and or post your comment. Please remember to click again so that you can submit. If you would like to receive project updates, you can now type your name, your address, your email address, and your phone number in that Q&A window. But if you prefer, and you would like to send your contact information directly to our project manager, please do so, and that is thomas.grela@fairfaxcounty.gov. And again, please include your name, your property address, your phone number, and your email. Our agenda for this evening includes opening remarks, followed by project presentation. Questions and comments will be addressed at the conclusion of this project presentation. Now it is my pleasure to welcome Mike Wing from the Providence District Office. Mike?
Yeah, thanks so much for the introduction. Thanks so much for the introduction, Ellen. Yeah, I just wanted to thank all the folks out there that are participating in this outreach event. Supervisor Pelchek gives her best. Unfortunately, she had some conflicts tonight and couldn't attend. So I'm sitting in to monitor this for her. Although Tom Grela is the point of contact for this project, if anything should come up and you need to contact the supervisor about this, I'm the point of contact in the supervisor's office. Feel free to reach out to me. But if you have any specific project questions, certainly feel free to start with Tom first. And I'll just leave it at that and look forward to tonight's presentation.
Thank you, Mike, so much for being with us here tonight. So leading us in this evening's presentation is the county's project manager, Tom Grela. Tom, the mic is yours.
Thank you, Ellen. I'd like to begin our presentation tonight just by introducing everyone to the project team we've assembled for this project. As Ellen said, I'm the project manager for Fairfax County. Again, my name is Tom Grela. I'll have overall responsibilities for the project, and I'll be managing both resources within Fairfax County itself and also coordinating work with our engineering consultant. Our engineering consultant for this project is a firm by the name of Whitman Reckart and Associates. You'll likely be hearing us refer to them as WRA. WRA was selected to be one of our partners on this project through their qualifications in similar projects. They've done almost essentially the same project for one of our sister counties, and they bring both corporate experience and the experience of staff to work with us on this project. Assisting me tonight is Andrew Castellini Dalbo. Andrew is working as the project manager for the WRA team. And both Andrew and I have been working together to develop all the project information to date, and will continue to do so as the project moves on through both design and construction. We have some goals tonight for the meeting. One of our goals is to inform the community about this project. We plan tonight to share some project background, but also the results of our study and our selected alternative. And we also want to begin tonight to understand any concerns the community may have on this project. Tonight in our presentation, we'll be reviewing some of the project background. We'll be presenting some information regarding our planning activities, which have been done to date. We'll also be presenting some future project work, meaning some of the design and construction related activities that will be coming up. And this detailed agenda provides more details on the presentation, but we'll be going into more specific information as we move on here. So this project is really about dealing with growth. Currently, people in attendance tonight probably recognize that Northern Virginia is a high growth area. And in particular, Northern Fairfax County right now is experiencing a period of high growth. The graph on the right here is showing two figures. The figure in blue is showing the current flows, and those show a current flow from this Northern Fairfax County area of about 90 million gallons per day. A million gallons per day is just a unit of measure we use to represent and quantify some very large flows. So our current flows are about 90 million gallons per day. We've projected future flows, and future meaning approximately year 2045, to be about 120 million gallons per day. That represents about a 30% increase in carrying capacity needed in our sewer system. In reviewing the capacity of the sewer system, we've noted that the current system does not have the capacity at present to deal with the future flows. So that's one of the reasons we undertook this project, is to deal with that issue. But what we also did find is, we don't just need to transport the flows, we also need to treat the flows. And we did find through our early studies that treatment capacity is available at the Noman Coal Pollution Control Plant. And that plant is operated by Fairfax County, and it's located in Lorton, Virginia, just to the west of Fort Belvoir. So to try to deal with this growth in the Northern Fairfax County area, we're actually doing a series of projects, and we've shown them here graphically. So we have a combination of existing and new projects. Two of the existing projects we're working on are some improvements to the difficult run pump station, and also some improvements to the Carter sewer located to the upper right here. Those two projects are both existing facilities. They were in progress to have some rehabilitation done to them, and we're adding some new features just to expand the capacity of the difficult run pump station a little bit. And we're also making improvements to the Carter sewer to assure that the pipe will serve us well for the planning period of this project. We have three new projects, the Tysons East pump station, the Tysons West pump station, and the Accotink gravity sewer. Folks may have been to a recent public meeting we had on the Tysons West pump station, where we spoke specifically about that project. We'll have an upcoming meeting in the future on the Tysons East pump station. We're still getting some information together for that. But tonight we plan on focusing on the Accotink gravity sewer and discussing what that portion of this program is about. So to speak more about the specific project for Accotink Gravity Sewer, I'd like to turn it over to Andrew to go into a few more details on background.
Thanks, Tom. Appreciate the introduction. I'd like to talk a little bit about, get the folks online to understand a little bit more about where this project is. So the map on the left gives an approximate location. It's in the center of Fairfax County, just outside the Beltway. What we're looking at is an existing sanitary sewer, and that's what's shown in the right-hand side on the green line. The existing Accotink Gravity Sewer starts up by James Madison High School, then passes eventually through Nottoway Park, jumps out to Nutley Street, and then eventually goes through and underneath I-66 and the WMATA rail lines. As the existing sewer passes south, it follows the Stream Valley through and under Route 29 and then Route 50 and terminates at the Accotink Gravity Sewer near the Cross County Trail south of Route 50. This is an existing sewer. It's in play and it's been working fine, and many people walk along these routes throughout the as pathways in the Stream Valley. Next slide. To orient the listeners a little bit more, the upper right-hand corner is a photograph of Nottoway Park, and what we have is a cross-country sanitary sewer, gravity sewer, that is characterized by going through some fields in Nottoway Park. As it continues south, when it jumps back into the roadways, it eventually makes its way over to Virginia Centers Boulevard, just north of the metro station. As the sanitary sewer goes underneath I-66, it follows a Stream Valley, and there's the photograph in the lower right-hand corner. It depicts a typical picture of where this gravity sewer is located. It's in a cleared pathway that's maintained by the county. As the sewer passes and continues to go south, it does go underneath Route 50, and you can see that in the lower left-hand corner, and that's what the roadway is. You could see the Accotink, the Hunters branch of the Accotink Creek is in the background. You can see the culvert with manholes in the foreground that depict where the gravity sewer is located just south of the road. The line then continues down to the main branch of the Accotink, the main branch of the Accotink gravity sewer, or the main stem. Next slide. So let me tell you a little bit of history of how this sewer was installed. It was originally installed in 1963. The sewer has been through some minor upgrades in 1978. And what we do understand about the sewer is that it is collecting sanitary sewer from this northern section of Fairfax County. And we have current capacity. The sanitary sewer has capacity to meet our current needs. But as you can see in the graph on the right, the projected flow that will be coming into this gravity sewer far exceeds the current capacity. And this is the genesis of why we have to increase the capacity or increase line sizes to be able to convey flow south. Next slide. So our study looked at 7 alignment alternatives, and part of doing this is to try to understand how to come up with the most effective way and most cost-effective, but also other ways to come up with alignments that don't impact the community. Out of the 7 alignments, we have 6 new alignments and 1 alignment that follows the existing line as it passes that I described earlier. The range of costs for these alignments range from 37 to 40 million. One question that when we looked at this, we tried to figure out how do we understand a little bit more about these alignments. And let me go to the next graphic because it shows how these alignments compare to the existing sanitary sewer. On this graphic, you'll see a dotted green line on each of the maps that I show. And in those lines, we show the alignment alternatives that we investigated. All the alignment alternatives start in the north, parallel the existing sewer, and then eventually pass all the way down underneath I-66 and eventually underneath Route 50 to the main stem. You'll see a lot of crossing over of the existing line, and that's done so that we can during construction we can actually have flow equalization when these systems actually get installed together, so that we can actually use both lines when flow is meeting this projected amount. Next slide. So when we have seven alternatives, how did we figure out how to look at and compare these alternatives? One of the things we looked at is we wanted to have quantifiable and qualitative data. So we looked at 8 different evaluation criteria, and they're listed across the slide that everybody sees. And they range from community impacts to hydraulic factors, constructability, environmental, land rights, utilities, and costs and stakeholders. Out of these elements, we could compare and start comparing and contrasting these various alignment alternatives to come up with the alignment that has the least impacts. And that's what we wanted to go through in the study and look at all the different impacts, whether it's stakeholder traffic or environmental conditions. For this group, I want to focus on 3 criteria. We can go to the next slide. These include, the ones I'm going to talk about, include community impacts, environmental, and costs. These tend to be, are just 3 examples, and they're not the only criteria we looked at, of course. But from the community side of things, we wanted to make sure the impacts to the residents' home and businesses are minimized, so we don't cause any extraordinary problems during construction. And those problems sometimes occur with traffic and detours and noise from bypass pumping operations. That when one of these alignments get installed, we have to be able to have the sanitary sewer run continuously so that everybody can have a continuous use of their systems. From an environmental standpoint, we also looked at the impact of these alignments on streams and parks. We wanted to make sure that we minimize those impacts into open spaces and trails, because this is a very active area within the county. And lastly, we want to look at costs. There's 2 parts of costs. You have initial costs, which is the capital side, but what happens is that the county also has to operate and maintain the sanitary sewer, and those costs are not insurmountable. So we quantified those to compare all the alignments so that we can come up with the lowest total cost alternative. Next slide. So the selected alternative includes roughly 15,000 feet of new sanitary sewer. With the criteria that we looked at, we selected an alternative that is mostly found in undeveloped areas along this route. We felt that this was the least impact in many of the criteria categories that we looked at. We wanted to make sure that we stayed cross-country and we paralleled the sewer in key locations so that we can have flow equalization when flow is starting to increase and we have to use both capacity in both sanitary sewers. The selected alternative has many interconnections, and part of our system has to deal with bypass pumping to make sure those interconnections stay live. And we'll be talking about that in a little bit. This system, because it's continuously operated, has to go through a series of bypass pumping, and we're going to talk a little bit about that in future slides. One thing I want to point out is our estimate is at $37 million. I mentioned before the sanitary improvements we looked at, these gravity sewer alignments range from 37 to 40. It just so happened this happened to be the lowest cost alternative. Next slide. So with that selected selected alternative, I'm going to pass the baton back to Tom so we can talk a little bit about what's going to happen in the next phase.
Thanks, Andrew. So all of the activities that Andrew went through were some activities that we've completed to date. What I'd like to do is talk about some activities we'll be doing on the selected alternative, and these activities will be future activities for the project. So the project will be transitioning from what we call a planning phase, which was the information Andrew went through, into a design phase. And during this design phase, we'll actually be refining the route of the pipe. So while in planning we have sort of corridors, when we get into design, we'll be actually locating the specific area the pipe will be in. So during this design phase, we'll be finalizing the sewer alignment. In order to finalize the sewer alignment, we'll be collecting a lot more specific data about the existing conditions in the area, what utilities might be present, and so on, to help us determine the best location for the pipe. As Andrew said, we'll be evaluating bypass of flow. Bypass of flow will be needed where we tie the new pipe into the existing pipe, and we need to deal with flows while we're doing that. We'll be using several methods of construction, and we'll be calling for those areas in the design we create. One of the methods is called an open cut excavation. The other is called a trenchless method. And we'll be going over those in a little more detail in a few slides coming up. We'll also be evaluating our easement needs. As Andrew said, much of the project will run cross-country. So while we evaluate that, we'll be looking at the current easements for the current pipe, and also be looking at the new pipe and determining whether any modifications to the easements will be needed. In areas of the project where we might be working in a street right-of-way, we'll be developing traffic control plans. Those traffic control plans will be to deal with the traffic and the impacts our construction in the right-of-way may have, and to develop good working plans to accommodate both the traffic and our construction. And also in design, we'll be doing a lot of permit-related activities. So our project will require various reviews and approvals. Some of the agencies we'll be involved with include Virginia Department of Transportation. They'll be giving us a permit for our traffic control plans. We'll be working with the Virginia Department of Environmental Quality. This project represents an expansion to the sewer system, so DEQ will need to be involved in approving those plans. As we go across country, we're likely to run into areas that are under the jurisdiction of the Army Corps of Engineers. And we'll be working with them in terms of their regulatory issues and requirements. And also we'll be working with Fairfax County itself. Fairfax County has various permits and approvals needed for projects in the county. So I'd like to talk a little bit more about some of these methods and just provide some pictures that might show these methods during construction. The first slide I have here is the bypass pump operation. Again, this bypass is used in areas where we'll be connecting the new pipe to the existing pipe, and it's generally used to transport the existing flows for treatment without impacting the flow of sewage to be treated. So the basis of the operation is a temporary pump, and we have the temporary pump in the upper left-hand corner here, and there's also another photo of it here. What this pump does is allow flow to be pulled out of the existing sewer and allows flow to be transported to another pipe downstream, another manhole, downstream. And that gives us a bypass of an existing pipe where we can then tie a new pipe into it. So we do anticipate the need to do this sort of operation, and we'll be evaluating it carefully as we develop our design. One of the construction methods we talked about during our design was the open cut construction method. This slide shows an example of that method. This is probably a method people are typically used to seeing. Many utilities use this type of construction method, water, gas, sewer, storm sewer as well. And this method is where a trench is dug for the pipe. We can see a trench here. A pipe is laid into the trench, and I just wanted to point out, in our case for sewer, generally our pipes are a little bit deeper. Reason for that being, for the pipe to work by gravity, we need certain alignments of the pipe. So we are showing a supportive excavation here. You can see this framework and these side slope supports here. That's for safety in the trench. It prevents trench collapse and allows workers to work in the trench safely. And that'll just be one of the many safety provisions Fairfax incorporates into the job. In any event, the trench is dug, the pipe is put in the trench is eventually backfilled, and then the operation moves downstream. So in this case, this operation, once this trench is filled, they'd start digging a new trench sort of in this area and continue down in this direction. And once the construction is completed, the road would be restored, and the only remaining evidence of the pipe would be the manholes that are located in the streets themselves. During this method, we'll definitely be dealing with traffic issues. So on the left-hand side, you can see here that there's a portion of the street that remains open for at least partial traffic access. And the other issue we'll need to deal with is local access. So on the right here, you can see one of the driveways that had to be accommodated while this construction was going on. Another example I'd like to show is still an open cut method, but this is in one of those cross-country areas or undeveloped areas that Andrew was mentioning. So in this case, we first need to gain access for all the construction equipment. So there would be access, developed to get to this work. Again, with the open cut method, we have a trench that's opened up. You can see here a different type of supportive excavation being used. These are the pipes that are eventually put into the trench for these sample photos. And again, the construction operation would find its way downstream, to continue construction. And then on the right, we're just showing an example of the restoration. Once the pipe is put in, the area would be fully restored. And I'd just like to point out, this is a dormant season. You can see there's no leaves on trees. It's a little bit brown here. But once the growing season came back, the area looked really well. The other construction method I'd like to talk about is trenchless construction method. And with this method, it's often used possibly for road closings for very busy major roads, and sometimes used also in environmentally sensitive areas to avoid impacts. With this method, we dig 2 pits. You can see one pit here in the foreground, the other pit would be on the other side of the road here. The 2 pits are used to house some specialized equipment, which would be located here. Specialized equipment would be used to tunnel under the roadway in this example, and between these 2 pits. And then once the pipe is tunneled, the pits become manholes, and the pipe can be put into service. This method requires some careful consideration. There's some technical issues associated with it. We need to make sure the conditions are appropriate for its use. Generally, that means the soils are suitable to support this type of construction. And we also need to consider the use and scheduling of specialized contractors. So that factors into how the construction project is planned out and scheduled. And there's also a technical cost issue. Generally, this method is quite a bit more expensive than the open cut method. So we'd really be considering to use this strategically to keep the project cost effective. I'd also like to talk about the project schedule. I'd like to talk first about these gold arrows facing up. These gold arrows represent sort of the public outreach side of our project. So we're here tonight in May 2022 for our public meeting. We're anticipating some future meetings, one in the winter of 2022 timeframe and another in the summer of 2023 timeframe. Those meetings are anticipated to correlate to some milestones in the project. So the navy blue arrows facing down show some of the more design and construction related aspects of the project. So we're anticipating in June of 2022 to incorporate any feedback we received tonight on the project into the project approach and also begin our design process. We anticipate the design process to be complete in approximately the spring of 2023. Once our design is complete, we would be bidding the project out to contractors. That bid process for Fairfax County has a bit of administration associated with it. We advertise our projects publicly for bid. So that process would take us out to approximately fall of 2023 to award a construction project. And we're anticipating an approximately 2-year construction schedule for the project. The other thing I'd like to point out is while this is showing some of our major public meeting and major public outreach similar to this meeting, we do anticipate much more focused meetings with specific stakeholders. So once we start to learn more about our project and where it is, we anticipate reaching out to these smaller groups and talking about specifics about the project in the areas they might be concerned with. And these smaller groups might be groups such as a neighborhood group, an HOA perhaps, or maybe specific owners and businesses near a particular area where the pipe might be constructed. So to summarize our presentation tonight, I'd like to review a few things. One is that the project is necessary. I think as we showed in our slides regarding capacity and growth in the county, we've demonstrated that there is a need for future capacity to assure proper sewage in the transport in the area. The project's needed now. I think our project schedule shows that these large projects take time to implement, and we want to make sure we get the project in good shape so that it's ready to handle the future capacity needs and really makes the project essential. So in order to prepare the sewer system for the future needs, we really need to go forward with this project. We reviewed some next steps in the project. One aspect we discussed tonight was the design development and the time we'll be taking to finalize the route of the pipe. So that will be some future activities we're working on. During that process, we'll continue with our public outreach program. And with that public outreach program, we'd like to get any understanding of concerns people may have and incorporate those issues into our project to mitigate potential impacts. So at the project conclusion, that would be when the construction is complete, this project will accommodate capacity needs for future growth in northern Fairfax County. And that's our presentation tonight. I will turn it back over to Ellen.
Tom and Andrew, thank you so very much for so articulately and clearly stepping us through the project details. Very critical project. As promised, when we first convened, I said after the project presentation, there is time now for your questions or your comments. So if you do have questions or you have comments, please now, it is time for you to type them in that Q&A window, highlighted make an announcement, type there, press enter, and then I will be monitoring your questions or comments and relaying them to Tom and Andrew. You might be thinking, Tom and Andrew, and reflecting.
Maybe while we're waiting, Ellen, I could just mention that we do anticipate posting some frequently asked questions to the project website in case we don't get many questions tonight. So that will be something we plan on updating to the project website.
Terrific. So I am not seeing any questions or comments, Tom and Andrew. I will encourage those who are attending to perhaps take a screenshot of your email, thomas.grayla@fairfaxcounty.gov. Tom is available to receive emails and answer any of your questions, take any of your comments. Also on the screen, you are seeing the website address for this project. And I also remind you, if you would like to be on a contact list, that you either can type your contact information now in the Q&A window or email Tom. So, Tom, I'm not sure if I'm seeing, can you talk a little bit more about the funding?
Sure. So this project is part of our capital improvements program. That's basically a program that lays out the funding and the resources needed to proceed with projects that are needed in the planning period for the capital improvement program. This project is part of that capital improvement program. The funds have been allocated for the project, and those funds are come from two sources. The funds come from sewer fees, which are part of your water bill, and there's also funding associated with, we call them connection fees, which are fees where developers would pay to connect to a sewer system.
Thank you. Again, at this time, I'm not seeing any questions come through, Tom and Andrew. We'll give it another 45 seconds or so. I don't want to rush people. I'm checking. All right, I'm not seeing any questions or comments. And I am taking this as that your explanation and the overview you gave us of this project was duly noted. And hopefully they have taken your contact information, Tom, so that they can be in touch when they do have questions coming through. All right. So with that, I am saying good evening to everyone. Thank you for attending. Do appreciate your interest in this project. And again, enjoy the rest of your evening. Good night, everyone.
Thanks so much.